If you're in the wrong room,
Close doors quickly.
How about Barbie dolls?
right, and Barbie dolls, of course, it can always be applied. These are agile multi-level marketing campaigns, so what a focus for these. I think we're ready to get started, and as I've been reminded, not yet.
You're at 4, right?
Yes, I'm sorry, Mike.
Okay, and because you got the virtual audience, they won't.
Right, that's what I was just going to say. Yep, absolutely. No
We
worries.
actually have about 800 people online.
Wow.
For this.
No, they divided up in three. So,
So you really
don't
don't
forget about that.
People are watching, Jim.
They're only
Never seen. 2 minutes. I'm going to start in 2 minutes.
Composition a little bit. Great, looks good.
So we can get started? Great, thank you. Hi, my name is Mike Sanka. I am very sorry for the delay. We had some technical difficulties, I guess, getting things rolling forward today. But I'd like to say hello to all the folks online as well, the virtual world. Please feel free to put your comments in, and we'll try to get those questions answered as well. We're going to move forward at a little quicker pace than we normally would because we've got a lot to fit in a short period of time. I'll be talking today with Jim Young, Dr. Jim Young, who is actually back at his old stomping grounds. Jim's a Berkeley PhD in statistics, but he's our director of predictive modeling and analytics. And today, we're going to talk to you about predictive analytics and how that works in the space of workforce analytics. eAuthority, our company, has been delivering analytics solutions for over 18 years to HR and other spaces as well. But without any further ado, I'm going to turn it over to Jim, and I'll see you a little later on in the presentation.
Thanks, Mike. Thanks for coming. Thanks to the virtual world out there, and hope you're enjoying your dinner. If you're on the East Coast, watching this presentation, I'm wondering if they can hear me if I go over here.
I've got a mouse here, Jim.
Do you want to
use to advance the slide? Just
right. Okay. So what is predictive analytics? I'm going to talk a little bit about predictive analytics and what are some of the benefits of predictive analytics. So if predictive analytics is so great, why isn't everyone using it? Well, there are a lot of barriers to predictive analytics. One is the volume of multidimensional data. So we have a lot of data, but it's not two-dimensional or three-dimensional data, it's multidimensional data, and it's very hard for us to visualize that data and to query that kind of data. So we need some very powerful machine learning tools, statistical tools to sort of mine that data. Also, I'm going to give you some examples a bit later on the difficulty of understanding results and the possibilities. So even your intuition can be quite wrong statistically. There's some very famous examples of that. Especially with high-dimensional data sets. So it's very important to have statistical tools that can actually give you the right answers, and sometimes would shock you. And of course, not everyone is a statistician, to say the least, and so it's good to have tools that can let the domain expert be able to mine his or her own data. So as you know, the first part of the problem is pretty much solved. We know how to store data, vast amounts of data, very cheaply and very securely. These slides just give you an idea of the enormity of how much data we have, and actually we're generating terabytes of data every day by remote sensing and all sorts of other sort of geographical sensing methods out there. So the predictive analytics, I feel like there was three major revolutions: the Industrial Revolution that gave us cars, planes, trains, and automobiles, and GM gave us GM, I guess, twice or three times. And I don't count it.
someone from GM may be here.
Exactly, right. Then we had the technology revolution, computers, data storage devices. And again, that got very cheap to store data and to manipulate data and to query data. And now we're in the information revolution where we can actually do more than just query data or just display data. We can do more than just Boolean queries like give me everyone making over 30,000, give me everyone who's been in the firm for more than 15 years, those sorts of things. We can actually answer questions that are much more statistical in nature. So for instance, in HR, you have data that tells you, where did someone get their their degree, how long they've been working, what fields they've been working, what kind of salaries, what's their history of salaries. All this information can be used to hire the right kinds of people and to predict how long they actually stay at a firm. For instance, there was an example I knew of predictive analytics that would say you don't necessarily want to hire the A student out of Stanford for your firm. Right? Depends on the firm. If you're Microsoft or Google, you might want to, but it might be better to hire the C person from Cal State Santa Bernardino. These people are hungry. They're probably not going to leave your firm. If they're a top A student from Stanford, they might come to your firm and work for a few months or maybe a year and then leave. So as I said before, the data we're kind of collecting now are very multidimensional. So we all know what one-dimensional data looks like, and we can do histograms of that, pie charts of that, and we can sort of digest that as human beings because we can actually see the data. In 2 dimensions, we can also see data. We can do scatter plots. We can do trend plots. Again, because we live in 3 dimensions, we can actually visualize 2 dimensions quite easily. And even in 3 dimensions, we can do rotating 2-dimensional plots to give you an idea of how 3 variables are related to one another. But our data sets have hundreds of dimensions, and so how do we actually see the data in 100 dimensions? We live in 3-dimensional space, so we're confined to looking at 3 dimensions. And so the questions we ask, the data we look at are, how does this variable relate to this variable? Or how do these 2 variables relate to this variable? Because we can see that. But what you really need to know is how do these 100 variables predict retention rates and things like this? We can't see that, but computers can, quote, see that. They're not confined to living in 3 dimensions. And so these predictive analytics tools can actually sort of see in higher dimensions than just 2 and 3. So I'm going to give you an example of some misunderstood results. This is a very famous example. It's very pertinent to predictive analytics. This is Bayes' theorem, and Bayes' theorem is the foundation of a class of statistical techniques called Bayesian statistics and Bayesian modeling, which are very important in predictive analytics. And it allows you to update your prior beliefs by looking at data. So you may have a prior belief about something. Look at data. It will change your prior belief to a posterior belief, and you can reiterate this process in a way that is not intuitive. So to give you an example, suppose we have the probability of some rare disease is 1 in 100. So to make this firm in your mind, imagine we take 100 random people and throw them in this room, say. So on average, 1 in 100 people will have this disease. Well, there's a test for this disease, maybe a blood test, and if it comes out positive, if you have the disease, it comes out positive 98 out of 100 times. Okay? So I have another room over there, not this room, but the room next to us, this room over here, and we have 100 people in that room we know have the disease. We give them the test, 98 out of 100 of those people test positive for the disease. We have another room, that room over there, where we have disease-free people, 100 disease-free people, we know they're disease-free, and we give them the test, and unfortunately 5 out of 100 test positive for that disease. So the test is a pretty good test. It has good accuracy and good specificity. So you go to the doctor, the random person, and the test comes back positive. Right? So the question I ask is, what is the probability or the chance that you have the disease? Should you get your will in order? Should you call your relatives? Should you be worried? So I'm always interested when I also teach at the College of Charleston, I'm also interested in asking my students, what are the intuitions around these probabilities? So anyone online or anyone, virtual people in this room, you are virtual, you're here. Anyone want to give a guess or a guesstimation about what the probability you have the disease is if you come back positive? So think about it this way. We have the room with random people. We have the room over there that have the disease. We have the room over there that are non-disease. And we have this room over here of people that come back and they're tested positive. How many of those 100 people that tested positive have the disease? Any guesses? 100%. Now, well, the test isn't perfect, right? The probability of testing positive having the disease is only 98%. So you say 100. So maybe 95%, 98%? There you go. What did you say? I think I saw you put a hand up. No? It's got to be high, yeah? Over 50%? Under 50%? Well, Bayes' theorem actually tells us the answer is quite shocking. The probability that you have the disease, given that you tested positive, is only 17%. Now, one way to look at that, and the reason this is important is this is surprising, and if we were to try to do our own data analytics by looking at graphs, looking at pie charts and histograms and different histograms and have a hunch about what it's right, we would be dead wrong and we would be making very bad mistakes, like making a campaign to hire certain kinds of people. So one thing is the test is very rare, it's only 1%. So the bad news is it went up to 17% when you tested positive, but still it's not near as high as people think. So this is, and Bayes' theorem is used all the time in updating our prior beliefs based on data. So that's why it's very important to have statistics and statistical tools that make sure that you don't use your intuition and get wrong results. Another one is the birthday problem, which is a very famous problem in statistics and probability. And that is, if you have a collection of random people in a room, like here or at a party or a wedding, what is the probability that two people share the same birthday? So I don't mean the same year, but the same birthday. We both have a birthday on October 1st, say. If we have, say, I don't know, in this room, suppose we have 50 people in a room. What are the chances that two people will share the same birthday? At least two people. Any guesses? Do we have any guesses online? Sarah? I'll give you a few minutes. Come on, folks out there. How about in this room? What's the probability of having a common birthday among 50 people?
50 over 365.
50 over 365, I get that answer all the time, right? So you just take the number of people divided by 365. If we had 365 people in the room, we know it would have to be certain, but that logic can't work because if you had 400 people in the room, your answer would be 400 divided by 365. Well, it probably wouldn't be, you would say it's 100%. But that's a common belief that it's just 50 out of 365, which isn't very high. Anyone think it's 50%, less than 50%? Let me show of hands, how many people think it's greater than 50%? Nobody. All right. So probably among 23 people is the break-even point. So you can make money betting even odds on 23 people in a room having a common birthday. For 30 people, it's 71%. And for 50 people, it's easy money. It's about 98% chance. Right, that's shocking. Most people go, that can't be right. Well, you can test it. Anytime you're at a party with 20 or 30 people, it's a great way to make money. I've made a lot of money doing that at funerals. It's always fun at funerals. It brightens it up. This again is one of these surprising paradoxes of statistical probability, and statistics is riddled with those. So human beings aren't really good detectors of probability and statistics. We really need tools to give us the right answers. Anyone recognize the gentleman on the left, lower left?
The pilots, the plane.
That's right, Hire Sully. So he has subject matter expertise. You in this room have subject expertise in HR or in work force analytics. So you know more about your data than I do as a statistician. Right? So in the old paradigm, we'd have a subject matter expertise needing some questions answered about their database. So they'd have to call a statistician or IT department and get a query and try to get that query answered. So the ideal for working as a statistical consultant, I do a lot of consulting, is I have to get inside Sully's brain. I have to know his data as well as he does. That's impossible. I'm never going to learn to fly 747. At least you hope I don't. But I'm an expert in statistics, and so we have to talk back and forth and try to get that. So the idea is to try to meld that expertise in domain knowledge with the statistician. So some other problems, opportunities, predictive analytical tools exist out there. Some of them are command line driven. You have to know how to program it to be pretty sophisticated as a statistician, as a programmer. A lot of them are command line driven, like I said. They're very difficult to use. And as Mike will speak to later, when something's difficult to lose, especially in our day and age, do we use it? I know I don't use it. I get very impatient quite quickly. There's a gap between the end user and the statistician expert. So we'll talk about this. So there's opportunities to try to meld these two together, statistical expertise with domain expertise. And the only way to do that, I see, is to have software that is very transparent and very data-driven. So data-driven model selection is a very key idea in what's called statistical learning theory. It's sort of artificial intelligence melded with statistics. So these two communities are coming together and talking to each other. The idea is if you have a big data set, humongous data set, multidimensional data set, where do you start? What even, if you even know some statistical programs like regression or ANOVA, these kind of statistical tools, you don't even know what kind of tool to use. The software will actually look at the data, understand the question you're trying to ask of the data, and will suggest a model based on the data. And we'll do diagnostics to see how good that model is. This is all done in the background. The user doesn't have to know anything about statistics for this to happen. So this is a key slide, is this subject matter expertise when it can overlap with statistical knowledge in the form of someone sitting in front of a computer using a very user-obvious, easy tool that has a lot of sophisticated mathematics behind it, can actually start to ask and answer their own questions. And that's the best thing, is to be able to answer your own questions and be able to ask your own questions. So by overlapping these two, I think that's where insight comes. Here's just a slide to kind of scare you. These are some of the tools that that we're developing at Authority for predictive analytics. And these are sort of cutting edge tools, and it's a very exciting time now to be a statistician, because a lot of these were just theoretical. We didn't have the computing power to do it, but now the computing power is there. It's cheap. The algorithms are fast. They're scalable. They scale to very large data sets. So these are some of the modern methods that are being used right now. And these are very, very hard to come by. I don't know many programs that have all these tools in them unless you're willing to sit down and program in SAS, for instance, and spend a lot of hours trying to program these tools. So these are some of the tools that we're developing, and they can answer lots of questions about databases, again, in a very transparent, data-driven way. So with that, I'll hand it back to Mike.
Great.
Thank you.
Thanks, Jim. I have a note here.
And Mike, if you would just stay at the mic to
Right.
hear from the virtual community, it's best to hear you that way.
Great. Thank you. Thank you, Jim. Before I jump in, I wanted to ask you a quick question. Sometimes I ask this in the very beginning. What was the single most, they did a survey. They surveyed scientists of all disciplines, liberal arts as well. They asked, what was the single most important invention of all time, ever? And if there are people virtually online who want to submit answers to this, you can. But this, through all of time, raise your hand if you have an idea of the single most important invention of all time. This was a survey, and in the end, everyone pretty much agreed with the number one choice. There was debate and question on other choices, but anyone want to take a guess? The single most important invention of all time? Fire. No, so it was not fire. Because humans didn't invent fire. The argument was lightning struck. Yeah, exactly. So something that was created by humans. Something light bulb. Light bulb was high. It was in the top 10, but it was definitely not number one. Any other wheel? No, wheel was I think 2 or 3 actually. Not the computer.
Diapers.
Not diapers. No. Someone actually said PowerPoint. I swear to God, in a presentation, someone said PowerPoint. It's shocking. No, the number. And I'll tell you when you go. Yeah, it is not debatable. The number one invention of all time was agriculture. And why? Because before agriculture, what did we do as human beings every single day when we woke up? Oh my God, what am I going to eat today? What am I going to eat today? We consumed our entire day worrying about food for that day. And the minute somebody said, hey, I've got the food thing taken care of, then Gutenberg had time for the press, Edison had time for what. So we had time to do these things and focus and specialize on tasks. And the reason why I tell that story is a good information architecture and a good solution that aggregates and consolidates information in much the same way as agriculture. It allows people in the organization to focus and specialize on their tasks and add value. You don't want to be chasing down data all day long. You don't want to wake up and go, where am I going to get the information? Where am I going to get the information? How am I going to get this answer? You want that prepared. So it's a really important concept, and you have to look and see how that affects. A quick question for the folks in the room. Show of hands, I would say sort of group A and group B. Group A would be you are more administrative and business process in nature, and group B would be you're more technical IT focused. So show of hands of people in the room who would say they're more A, more on kind of the business side of HR, and then show of hands of people more on the technical side. Okay. Show of hands of people who are statisticians who have experience in predictive analytics, have used SAS, have used tools like that in the past. Anyone? Okay, great. Just want to get an understanding of the audience and some of the issues. One of the big issues that we talk about with predictive analytics and why it's been a big barrier for people for a long time is that it's always been strategic in nature, and they sort of talk about 5 guys in a basement with SAS. That you develop strategic models with predictive analytics, with data sets, and then you try to apply those data sets. And one of the big issues with that is we have a very dynamic and changing environment. And all you have to do is look to the fall of 2008, and there were a lot of predictive models that didn't accommodate unemployment rates. And those models no longer worked. And Jim said that what happens a lot of times when people develop predictive models and they're not learning models and they don't update is sort of like living in France, getting a very detailed map of France, and then moving to Germany and going, oh boy, but we spent a lot of time on that map in France. We got to make use of it. And people do that all the time and get bad answers. And nobody's models were working in the end of 2008. So moving to an operation will require several things, but one of the big issues is for predictive analytics for the masses is to convert stakeholders from spectators into participants. And that Jim was talking about getting the subject matter experts in that. Predictive analytics helps us define things like, do you want this person as a customer and do you want this person as an employee? Very, very important things. Agility, accessibility, and completeness of data. And these are really three important factors, once again, because if you're going to utilize and make predictive analytics operational in nature, involve it in dashboards, involve it in decisions on a weekly and a monthly basis, not just a semi-annual process, you need agility. And agility means that your predictive models have to adjust to the new data, the data you just picked up yesterday or the day before, the new dimensions that you pick up, and we'll talk about that in a minute. And then accessibility. The people who know and understand the data actually have to be able to interact with that information to get the right learning set. And when you develop a predictive model, it's all about the population of data that you're looking at. And the people who know the population of the data are the business users, not the statisticians. Completeness of data is another really important aspect when you're looking at predictive analytics for your organization. One of the big mistakes that often get made is people borrow predictive models or techniques from other organizations. And you have to understand that any model that you ever borrow is a least common denominator model. And it describes a problem or a situation with a bare minimum number of elements because they say, well, geez, we know everybody's at least got their hire date, and we probably also have their age, and we probably, and so they don't have your testing methodology, your techniques, your scoring systems. They don't have a rich set of data that your organization possesses to develop that accurate model. So it's really important. The agility problem comes down to this, and we call it the external request. That you have a business user who has a question and they go to a statistician. So they pick up the phone, they make a call, the statistician works on it, cycles something back, possibly in 2 weeks if they're lucky. A lot of the typical reports say 6 to 8 weeks on this, but the first time through we know we never get it right. It's never done right. So you go through multiple cycles, and this ultimately takes months. It's an exhausting process. The solution to this is to allow that business user to make that request and fulfillment on their own. And so we get a cycle down to minutes, and this allows them to learn in that process. The accessibility problem, when we talk about a traditional UI, we look at the accessibility cycle, and we have interest, adoption, and retention. Those are the major aspects of someone utilizing the system. And I've got an interesting example about utilizing something. But we talk about having a user-obvious interface or a user-obvious solution. It goes beyond user-friendly. User-obvious means that the user, like a browser, you talk about an explosion of use on something. We're in San Francisco, so it's a good example. For the 49ers, gold was accessible. It was in the top. All you needed was a pen. You didn't need mining equipment. It was very accessible. That gold had been there a long time. It came to an accessible place. People were able to get to it. The same thing with the internet. It was available from the early 70s, but it wasn't until the user-obvious interface came out that this unbelievably powerful resource was accessible. The same thing exists in all of your organization. There is a wealth of information and knowledge that can be utilized for predictive analytics. It's about getting the right interface and access to that information to make powerful decisions. User-obvious design is about being simple and visually compelling. It's got to be self-teaching. You've got to use progressive disclosure, as they sort of say in Shrek. It's like an onion. You've got to peel back layers of the onion. Personalization. As human animals, and we research and study interface design a lot, and that's for an entirely different talk, but as human animals, we not only do we nest, but we leave breadcrumbs. And effective interfaces allow us to personalize, because it's a hook for us to come back in to where we last were in an application. So learning systems are very important for that process. Okay, now a Monty Python reference, a case for simplicity, now for something completely different. In 2008, the American Heart Association changed the CPR guidelines for first responders. Is anyone aware of this? Do we have any sort of first responders? So you aware of the change they made? I'll tell you, for those of you who don't, I'll tell you about the change they made, but it's pretty amazing. But these pictures actually come from the American Heart Association website. They used to hang people upside down when they were heart attacks. The inversion method. Then there was the trotting horse method, so they throw people over the top of a horse. And then my favorite is this last one. The American Indians would fill an animal skin with smoke, insert it into a lower orifice, and this is where the term blowing smoke up someone's ass comes from. So, can't say you didn't learn anything today. But what they did, what they said in 2008 was skip breathing. If an adult, this doesn't apply to children, but if an adult is down, they said, don't worry about breathing, just start chest compressions immediately. Because the out-of-hospital survival rates, when you had, and I was a Boy Scout, it was, tilt the head, check the airway, lift the legs, 15 and 2. If you were on your own, 5 and 1. It was a very complex system. When they said, just forget all of it, don't do breathing, just start doing chest compressions, out-of-hospital survival rates went up from 2-3% to the low 20 percentile range. And so the reason why I bring this up is, as technologists, we always think one more button and one more draw, you gotta have it. It's really important, you gotta have it. But what ends up happening is the patient dies, i.e. no one uses the software. So simplicity is a really important aspect of design. And like I said, it's a very tough thing for technologists to get, to kind of say, well, we can't stop breathing. Well, you can. And more people live and have value because of it. Completeness of data, another big challenge for HR especially when you talk about predictive analytics, because developing an effective model means a complete data set. It means not just information from one of your providers, but from all of your providers and from the data that you're collecting on your own. And that means that no one vendor is going to be able to provide that solution to you, that you're going to have to own that and move that process forward. Okay. I'm going to jump over and do a quick case study. In a minute, I'm going to have you flip the camera over to the screen, but I'm going to prep that. And Jim, I don't know if you want to take any questions while I'm
Yeah, I'd be happy to.
jumping over to...
Anyone do the math and get those answers that I gave? Do you have any questions? Any online questions? Yes, questions.
Questions.
Thanks.
What about, I'm sure you're familiar with black swans and
Yeah.
the concept of the black swan, which basically,
There are no
as I
black swans.
understand it, as I understand it, it's the other side of the story, which is that there are certain phenomena that elude statistical definition or statistical predictable modeling.
Right.
And, or I should say certain data sets, types of data, distributions that are abnormal, for example. Where are the limits of effectiveness for predictive modeling as it relates to the data that we have? We've got lots of different kinds.
Right, that's a good question, and I think it's the statistical expert would never find the black swan, right? Because the statistician would say, based on our data,
Right.
there are no black swans. But if you had an expert in species or species development, that expert would domain expertise together with statistics might suggest that no, it's actually possible, even though the data says it's not possible to have that. So I think what are called Bayesian networks are sort of the most promising field for things like trying to detect causality. You can find certain correlations in your data set, doesn't mean it's going to be causation. A child's foot size, shoe size is correlated with their intelligence, their reading level. Well, it's not because big-footed children can read better, it's because they're both correlated to age. So these Bayesian networks and with domain expertise allows a user to actually tease out causality over correlation. So I think that there's no doubt that the domain expert still has to be the one that's sort of governing the data and asking the right questions. And the Bayesian model can allow the prior knowledge of an expert to be put on top of the data, and then the data updates those prior beliefs. But there's certainly some questions that are beyond statistics, especially if we don't have the data to answer them.
Right.
In the case. But it's interesting to note that the black swan case, a Bayesian statistician would say, actually, if we put the right kind of prior on that, the probability of a black swan will not be 0 to a Bayesian, actually. It would be actually quite small, depending on if we see 10,000 white swans. But that's a good question. But I think the domain expertise along with the statistical, that iterative nature is where insight comes.
Well, where I think it's particularly relevant for organizations today is innovation becomes a competency almost, right?
Right, like what if scenarios.
Right.
Yeah.
So how do you, it would be great to be able to predict where you're going to get innovation from, but that's what it seems like the whole thing starts to break down because.
Right, because the statistical analysis is based on sort of a learning data set or data sets that happened in the past. So innovation, especially genius kind of innovation, can only right now seem to come from human beings. So.
Yeah.
But I think there are statistical tools, I can talk to you offline about that can actually sort of predict where innovation might come.
Good.
You can turn the camera up onto the monitor. Now, it may be a little difficult to see. The projector is only putting out 800 by 600 as a maximum resolution, so that's why it looks a little fuzzy. I've got a data set up here, a data set that's been imported from multiple disparate data sets. And there's an aggregation phase that occurs with the data, and I'll pull up desktop. One of the first things that you have to do is pull in multiple disparate sources. So we've got data sources here. I've got my PeopleSoft, Oracle financials, and a spreadsheet that I've pulled together. That information has to get modeled. Look like a Vegas lounge singer here with that. That information has to get pulled together and consolidated into a centralized data book. So what I'm going to do here is I've got my PeopleSoft system where I've got active staff. I'll drag that down into my root data book model. I'm going to drag monthly payroll into there. In Oracle financials, I might have monthly expenses. I'm going to come back here, grab object codes, and grab projections. So you have to model, one of the first things that you have to do is model that data, get your baseline set up. So I'm going to jump forward to that completed data set. And what we're looking at here is the sort of denormalized set. And I'm not going to go through and demonstrate the whole solution here. I'm going to jump right to answer Rich. But what we're looking at is staff information. And we've got review scores. Like I said, I realize online that may be difficult to see. I can zoom that in a little more. But we've got their hire year, the recruiter, the source. We've got some SAT information actually on these people, what their review score is. An online learning system, we've got LMS hours, what their department is, job title, salary. So we've got a wealth of information pulled in from multiple disparate systems. And what I'm going to do here is go into Answer Bridge. And what it does, the first thing it does, once again, sort of user obvious, is, hey, what do you want to predict? Please drag the variable here that you want to predict from your data set. And so what we want to predict is their review score. How well is someone doing in our organization? The next step, we can pull all variables or we can select variables. And what we're saying is, well, we want to see what's going to predict a good review score for somebody. So we might say, well, LMS hours might have an influence on that. We'll throw their SAT in here. And let's see what else we have. And maybe their salary. And what we find is it's saying, hey, LMS hours is actually the most influential of all this information on this person's review score. And then it's SAT math and SAT verbal, and then the person's salary. So it gives us an idea, and we can actually enter values in there and go through and predict a result if we had a candidate coming in. What do we believe their review score would be based on those factors and variables? But to jump back out, let's say we were looking at, and I'm going to look, we've got a lot of different recruiters here. I'm going to see if I can. Oh, let's see, I know that Hinsky's candidates are different. So if I want to filter just Hinsky's out of this, I can simply grab Hinsky and drag it up to the filter criteria. And it'll filter down to Hinsky. And if I go back in and go through the same exercise and say I want to predict review score, select my variables again, look at LMS hours, SAT, and I think it's Hinsky that this changes for if we sub-filter their information. And there's salaries in here, I skip past that. We can see that only LMS hours and SAT math matter for Hinsky. So the important point to note here is the model changed. So for the subpopulation of Hinsky recruiter, and maybe Hinsky's recruiting just salespeople, or maybe Hinsky's, it's different. Those factors are different, and what drives that is driven by the data, your data. Once again, the model has to be driven by your data and the variables of your population set. It's a very common mistake for people to think, hey, we've got a predictive model, it worked really well at one organization, or it worked well in one division. And the only person who can actually filter that data to the appropriate set is the business user. It's not the statistician. It's the reason why physicians have to sit next to epidemiologists with medical research. There's something called bimodality in data where they'll try to normalize the data set and they'll say, well, we're really trying to get an answer here for what's causing this disease. And if it looks like there are two different populations, there isn't a computer program in the world that can actually determine why there appear to be two populations. But the physician says, oh, you know what, it's because we have smokers and non-smokers. Let's just go filter out the smokers, or it's because we have men and women in this population. So it's important when we talk about having an agile solution that, they can say, well, we really should filter, maybe we should just filter by source. and we want to group by source. We're saying only agency or only referral, because we think that's influential in the model. So having the ability for the user to go and change and cycle through that data set is a really important aspect of developing an effective, reliable, predictable model, something that you can use on an ongoing basis. Any questions about that? And for those people online, Sarah asked me to say you can put a tweet out, and we've got a lot of information as well on our website, and you can contact us as well. So I want to jump into another aspect of predictive analytics, and this is actually something not before seen. So for those of you who are familiar with predictive analytics, this is actually a brand new visualization device that we are going through a patent and an IP process on, and we'll describe it here a little. It's called the Variance Map, and minimize this here. And the Variance Map, it's not something at first glance that you can sort of immediately understand, but with a quick explanation you can. And so what we have here is says performance review. And on the y-axis we have the magnitude of the measure. So we have a performance review that goes from 1 to 4. And on the x-axis we have variance from another measure. So we have 0 to positive 100% to the right and 0 to negative 100% to the left. Well, what the variance map, these yellow dots are individuals in the organization. And what the variance map does is it shows you data dynamics. So as Jim said, the human being is still irreplaceable, and has said in the past, the human being is still irreplaceable in this process because of the way we relate and understand the data. So what we're looking at here is we can see these are the employees that are consistently high, and not stone, but meaning good performers. Scoring between a 3 and a 4 on a regular basis. And these are our employees that are consistently low review performers. But what we're seeing here is, this is their score, but this is their variance from their previous quarter's review. But now we've got rising stars. And so this person who's at a 3.1 is actually different than this person here who's at a 3.1. And why is that important? Well, this is where the human element comes in. Because if we want to learn how to really motivate and move these people who are in the yellow box, we're not going to learn from the people who are in the green box, the consistently high flyers. Their behavioral habits are probably not things that we're going to readily translate to the people in the yellow box. But the people in the orange box, they were in the yellow box just a quarter ago. What happened to them? Was it their manager? Was it training? So we learn more from the data dynamics than we do from direct saying, oh, let's just emulate the people who are typically high. What about these people who fall from grace? It's very different to have a 1.1 who used to be at a 3.0 or it used to be than someone who's consistently a low performer. So the variance map is a great thing because it can really be applied to a lot of different types of data sets. And as a lot of our customers and clients as we're rolling this out like it, it's sort of becoming the favorite tool because they very quickly sort of understand the dynamics of the system. If we were to look at expenses and look at a budget in a department, all of a sudden it has a very different meaning. So now we've got our, this is a $2 million to a $0 budget, and this is variance expenses that vary from that budget. So now we see, hey, these are our trouble spots, right? So we've got someone with a $1.75 million budget who's 40% over. Well, this person's 90% over, but their budget's tiny. I don't care about that. So once again, now all of a sudden I'm concerned about the upper right. I've got my effective managers who are at or slightly below budget. Well, these people way below budget, is that a good thing? I don't know that that's necessarily a good thing because that might be a late surge coming and I may need to fiscally plan in a different way. So the variance map is a new generation of predictive tools, and that's and a big focus of the variance map is to make predictive analytics tools more accessible to the non-statistician individual. So I'm going to jump back to. You can throw it back up to the podium. Okay. Okay. So we look at the past and we look at the future of information and how that's getting managed in HR. And if we roll the Wayback, the Mr. Peabody Wayback Machine back to 1980, when initial management reporting came out, it was a very manual process. In the early 90s, we had ETLs that started to facilitate the automatic extraction of that data. In 2000, BI came in, right? So we aggregated that data, we pulled it together, we were able to start analyzing it. But there were still a lot of problems for accessibility. And the promise of BI delivering answers, especially to HR, never materialized for a lot of folks. And the reason why it didn't materialize was it lacked extensibility, it lacked accessibility, agility. There were a lot of issues that faced. Really, the devil was in the details, right? As we look at 2009, 2010, and beyond, as we start to develop more extensible, and in 2012, developing this neural network of information, we see a connected environment, and we see organizations like yours connecting with peer organizations, non-competitive peer organizations, to begin sharing information so you can start to benchmark and develop more effective predictive modeling around how your employees are going to behave, who you should be hiring, and one of the big issues and one of the big benefits that predictive analytics can deliver is early remediation. And one of the things that I think probably a lot of folks can appreciate, and happens very commonly in HR, is we face problems when they're in a stage 4 disease, right? Healthcare is all about early detection, early monitoring. If you have high cholesterol, you don't die from high cholesterol. High cholesterol is a sentinel event for disease. They say, well, if you have high cholesterol, we know in 10 to 15 years you're going to have coronary artery disease. So what we're trying to figure out is what are the sentinel events for folks in your organization so you can remediate activities or behaviors, intermediate on those early so you can solve the problem, make them a high performer, because the cost of employee replacement and retention is obviously a big issue that faces all organizations. I think we're right up towards our question and answer session. That's a very quick overview of predictive analytics, the basics, the intro, the science behind it. This is me getting stuck to the cord. We'll open the floor now. Jim, if you want to come back up, we can open the floor for any questions that you might have. Sarah, I didn't know if there was anything that I failed to add that you want me to repeat to the folks online or in the audience.
I enjoyed it. I hope everyone else has as well. And just if there are questions, repeat them so that our virtual attendees can hear them as well.
Great. Questions?
How about the data issue? I'm in this environment in which we have different platforms, different sources, and different levels of cleanliness of the data. How do you work with that to get it into a model that you can utilize?
Great question. So the question was, how do you integrate multiple disparate data sources so you can ultimately develop a workable model? And so that is a challenge that all organizations face. And one of the really important things is whatever solution that you choose, you have to, and it's our belief, and what we've seen in almost 20 years in this process, is you have to make sure that it is forgiving of change, that it's agile, and you can do it in an iterative process. Way back when we used to develop data warehouses, operational data stores, it was okay, let's spend a year doing a really detailed specification, because if we get it wrong, it's going to be really painful to change it, and that model is broken. It just doesn't work. So spending a massive amount of time to try to do that specification means that the system is unforgiving of change. So you start with a core data set where you have primary value, and typically that can be done with one or two sources, and then you begin to build that data. You identify pretty quickly where you're going to have data issues, cleanliness issues. Our technology platform allows that to be plugged in and out very quickly, and allows you to replace that system and clean it without breaking your model. So it allows you to push through. But I would encourage any system that you look at or any process that if you're 3 months into it, replacing or updating any system is not going to cause a rebuild of the system. It's once again, I can't emphasize enough how important it is to have a system that's forgiving of change.
And something about the cleanliness of data too. A lot of data sets that have like maybe one missing value. You have, 25, 30 rows of good data, and you have one missing value. A lot of the tools there will just absolutely either take that variable out of the analysis for everybody, or take that individual person out because they have one missing value. So the tools we're developing are very robust in that they can either impute or sort of guess that missing value, or they can be robust to still use that person's data or use that important variable, even if it's missing for even 10% of the population, they can still use it. So a lot of tools just literally throw out data that's only 10% bad.
Other questions? Yes?
What's the statistical engine you're using?
The statistical what?
Statistical engine we're using.
The
Because
statistical.
it's data mining, right? And so what would be?
Well, some of the tools I've mentioned up there support vector machines, neural networks, some Bayesian ideas, Bayesian nets, some traditional tools as well. Because I mean, some people say, well, I want, especially if you're like work for the FDA, they require certain kinds of statistical analysis, like multiple regression, very simple linear multiple regression. So we do that as well. But again, the statistical engine that we use is again data driven. I couldn't say for a particular data set what our platform would actually use as a model. Does that make sense? I just wouldn't know. It could use a neural net with a certain kind of architecture, or it could use what's called a support vector machine.
So if we have SAS, we can layer this on top of SAS.
I'm not sure what you mean by layer on top of that. If you have existing SAS code, you mean?
Yeah, or SAS predictive engine can use the statistical models or within that. Because I don't know, I can't get it. I'm not sure what you're doing. Are you building your own statistical models?
Yes, absolutely. So some
You're
of
not
the
using a SAS or on top of R or anything like that?
no, absolutely not. Ours are written from scratch. So that's very important too, but we do QA against R and S and SAS, make sure some of the more traditional statistical methods like multiple regression are getting the same right answers out. But we're a big proponent of, at least I'm a big proponent of data-driven models. So.
Thanks.
Other questions? Well, if you have any questions and you want to stay afterwards, please feel free to do so. And once again, we can be contacted, Sarah as well, you said sales@authority.com. Thanks everyone for coming, really appreciate you taking the time. Thanks for everybody online as well for taking the time.
Thank you.
Thanks.
If anybody does want some literature to take with them, I put a few things up on the front table, or you can drop a card if you want to submit a specific question or follow up. We can send you the links to this presentation as well as maybe a deeper dive into how we combine some of those data sources that you mentioned specifically. Thanks again, guys.